Hello, all. This is a podcast about light waves. So, my name is Alexander Elias. It's May 2nd, 2015, and my instructor is Corin Rambach. So, now, when most people think of light, they think of the sun or the moon or the ceiling fan with the light coming out of it, or a lamp on the desk of some sort. But light is it's much more than even the sun and the rays that we see, or the light from the lamp that is visible, or even the ability to see color at all. It's more than these things. It's a lot larger than what I certainly knew about, and it's called the electromagnetic spectrum, or light spectrum. And it spans from the highest frequency of gamma rays all the way down to the lowest frequency long waves. And we have radio waves and microwaves and visible uh, light in between that also. And we can see even from this diagram here just how small the portion of light that we interact with constantly. Well, I guess radio waves we would interact with constantly too, but at least visible, that we to see or for color, the portion of that is really quite small. And actually, if you come up with a percentage with it based on the frequency ranges, it's about 2.3% approximately, which is pretty small. And so, if we only used this amount of the light spectrum, it'd be unfortunate. But fortunately, we have quite a few resources that can utilize this natural source of light and or the electromagnetic spectrum. So, as stated, we're talking about invisible light now, not necessarily the visible light, and more specifically, radio waves is the kind of more the focus of light that we'll be honing in on. This is a nice diagram because it's got kind of gives you a bit of a visual of what a wave is. Not that low the lower waves actually flow into the higher waves. That's not necessarily how it works. Although the break between there's not a distinct break between, say, microwaves to infrared, or infrared to the visible light spectrum. It doesn't just suddenly drop off. It's actually a gradual gradient from one spectrum, or from one category of or section or block of frequencies to the next. And some of the sources that you utilize radio waves are antennas or computers or mobile devices and whatnot. So we're going to talk a little bit more about hertz and frequencies. What is hertz, and or Hz, the abbreviation? Hertz was actually a man that discovered the radio frequency and came up with the name there, Hertz, or is named after him. His last name, I believe. And this is a nice diagram from Wikipedia, and it just demonstrates a little bit better um, the hertz on the prior images. Hertz wasn't actually listed on there. This actually shows you, from the extremely low frequencies to the microwave frequencies of 300 gigahertz. Um, so, so we have here the abbreviation HZ, which typically we just see that. Now, there's actually the abbreviation on these above it are actually a little bit longer. We have a K, an M, and a G attached to them, and these represent kilohertz, megahertz, and gigahertz. Now, pertaining to radio frequencies or radio waves, we have obviously the block here of 30 kilohertz all the way up to 3 gigahertz. So, and that is what they're saying microwaves start at too. Now, so kind of an interesting fact here is that microwaves actually utilize the same frequency that Wi-Fi does, or Wi-Fi utilizes the same frequency that microwaves do. Just the microwave frequency is a bit higher in the spectrum, so that it ends up vibrating those molecules to the point that they begin to heat up. And so also the mobile or cellular devices typically use the 800 megahertz spectrum to about 2.8 gigahertz spectrum, and in general you don't see it listed as 2.8 or gigahertz for that matter. They generally, for some reason, still listed as 2800 megahertz, which is the same thing as 2.8 gigahertz. Now, we don't really have anything higher than that yet that is in use to the public, at least, provided by your common service providers. But 5G just came out recently and is, I believe, being sold by the FCC, or has been sold, or has sold some of its frequencies to the carriers. So that could change things. Maybe we'll see some higher frequencies depending on what they're trying to do. Although I believe they'll be in a lower frequency because it was said that the 5G would be able to penetrate buildings and walls a lot better, thicker buildings and thicker walls better, and typically the long waves, which would be anything in the lower spectrum, that would be long waves. Those penetrate farther, or excuse me, those travel farther distances, and they actually penetrate objects better than the smaller waves do. So in that case, you have to have, for something more like microwaves, you have to have the source of provision of the frequency a lot closer to the device that is attempting to use those frequencies. And common misconception is that 3G or 4G or 5G is actually the frequency or the gigahertz or the hertz level, which obviously isn't true. And I was deceived by that for a long time, just out of ignorance. But it actually represents generations. So there was 1G, 2G, 3G, 4G. Even though we don't really see those, those are just the generations of technologies that were used to transmit and receive the frequencies or the waves, the radio waves. So 4G, actually, there's no difference. in the frequency necessarily, although 4G typically has a higher frequency in the spectrum. So I did an experiment, and it was just a quick experiment. I called my wife, and I wanted to find the time, or the goal initially was to find the speed it took, to see if there was, some information that could be gained from that, such as discovering what frequency was being used, if I knew also the distance, which she was at Walmart, and Walmart was 12.5 miles from my house where I was located, and it took about 14 seconds for the call to for her to answer the call. And that was on the first ring, so that would have been as quick as it could have been. I took the simple velocity equation here and used distance over time, which gave us 144 meters per second, and I did the conversions and whatnot in Google. So now, knowing that light travels at 300 million meters per second, neglecting our atmosphere, you would be thinking, like I was, what is the point, or how is it that the frequency would be so slow? And this is a wise question to ask, except for the fact that there are plenty of reasons of why this could be happening. One is there's towers in which the signal has to be transmitted from the device to the tower to most likely the other tower in which the other receiving mobile device is located in. And those have to ping from one to another until it gets there. So this could be the time, plus there's some programs that have to run also in this case from one to another to verify the data packages and the phone numbers and actually find the device and whatnot. So this relates to my degree, obviously. I'm in mobile development at Full Sail University, taking my computer science degree there, and really light does in many ways, but more specifically radio waves and how that is used by mobile devices or cellular devices. So here's my references and resources, my images and whatnot, and thanks for watching.